Sally, if you wouldn't mind just kind of picking up on this, what were some of the big takeaways that you came away with when doing your research and when writing this?
Yeah, totally. Thanks, DJ. I was talking to DroneUp about how all these tests went. They're testing drone delivery through all sorts of factors, and they did sort of like all these A/B tests. And something that really just stood out to me was this test of flights of humans piloting them and the robots actually doing the work. And so, yeah, as CJ said, the humans piloting the flights often move faster. The reason why is because human pilots actually fly faster. The manual controls are set to have the drone fly a little bit slower. And I do wonder, over time, as the robots get smarter, if the robots themselves can actually fly faster and catch up to the human pilots. Of course, the big differentiating factor is human pilots were less consistent. So in a case where you have to fly the exact same route, and I mean, down to the inch, then a manual drone is always going to do it better. But what really stood out to me is what the report actually said, is they sort of kind of analyzed this whole phenomenon, and it said that there's resistance to the black box effect, where pilots don't know what the software is doing and they don't trust it. Right. Part of it is an ego thing where their skill is on display if they are flying, which I thought was so funny.
Yeah.
Paul, I'm sort of curious, are your flights primarily human piloted or are they manual?
So, yeah, I'd say both. And it's interesting reading that article that you had with that, because I see the same thing in certain areas. So, for instance, like doing a bridge. When you've got to fly around a bridge, automation is an absolute no-no, right? You're going to run into the bridge using automation typically. Even with the sensors, especially when you get underneath, you lose GPS. So you've got to fly manually. In fact, I tell most of our pilots the way we train them is to fly without GPS or in ADI mode, depending on the aircraft they're in. That way it's not a surprise when it suddenly disappears and the wind's blowing and you're getting close to running into something, right? So I could see the manual aspect of that. Now, for mapping, when I'm out mapping, there's no way I can fly a consistent map perfectly with an overlap. It's just nearly impossible to do. You can kind of do it, but as you said, you weave in and out. It's not exactly a good grid. So for that, I love the automation, even though it's like watching paint dry for some of the bigger missions, right? But you get a more consistent product out of that.
I am sort of curious about drone delivery. It's sort of like this hybrid. If I hear the bridge example and I hear the mapping example, those totally make sense. Right. And drone delivery, I guess it could go either way.
Yeah, where I see though on delivery though, when you think about all the aircraft that come into the sky, you almost have to have automation, right? Because if you look at the accident rates just with cars, then how's that going to work when they all go into the air? If you look at aviation safety record versus the automobile safety record, it's much better, right? Last year, unfortunately, over 37,000 people died in automobiles. And that's also my argument why urban air mobility might be awesome, because in aviation, I mean, safety record's a lot better. I think it was last year they had one commercially fatality. If you look at all of general aviation and aviation, I think it was somewhere around 300 or so. But you look at the 37,000 in an automobile and people are like, oh, I'm scared to fly. Well, you should be more scared to get in your car, right?
Yeah.
So.
And where are those accidents in general aviation? They're probably smaller planes, right? Individual operators, less sophisticated autopilots.
Yeah, absolutely. But I think the key is when you get all those aircraft in the sky for drone deliveries, they've got to be somewhat automated because there's going to be so much traffic. We've been working on a simulator testing all that in coordination with the University of Utah, seeing what happens if we put a vertiport here versus one here. How many aircraft can we have in the sky? What happens if we put corridors here? And it was interesting. If we just let everybody fly wherever they wanted, the system broke down really fast. Yet if we had highways in the skies, we could do a lot more efficiency and it worked a lot better. But with that, it kind of needed the automation for how do you coexist when you have the package delivery layer and then you have an aerial passenger vehicle layer. So for those to coexist and be able to fly around each other, they need to be able to talk each other, to see each other, know where they're at. And could you do it manually? Probably. But once you lose your eyes and you're flying from somewhere else when it's a longer distance, I think that's where the things change. If you can see it all the time, it's probably easier. But what happens when you're 5-10 miles out and you can no longer see the aircraft?
Yeah, I think it will be a game changer when things like Skydio become more prevalent, where you have all these sensors and drones really can avoid crashes. I wonder if that will give people a little more trust in the robots.
Yeah, I was thinking about this the other day when I was driving my car, because somebody, gave me the wave to go, right? So that's a form of deconfliction. And that's not actually possible if you have multiple pilots piloting from a distance, right? There's kind of like, any simulated view is more restrictive. It's a two-dimensional representation of space. So in order to scale, you have to have that automation. So egos will have to be, I guess, couched.
I love Mike. I love what you said about the egos, because I think ultimately that's what it really comes down to: is we all think we're smarter than the robots.
Yeah. Well,
yeah, and there's certain times too when you're manually flying, just it looks different, right? You might think an obstacle may be further away or closer than it really is. And by utilizing the sensors or cameras, you can kind of see better and using all that situational awareness. But again, some of those areas are hard. We'll have visual observers with radios helping out on that for some of those complex things. So at the package delivery, if you're trying to weave in and out of some areas, like imagine trying to fly through New York manually around some of those when your eyesight's limited. So that's where I see some of the automation and mapping. And that's probably where it's key to have a lot better data, which the drones can provide, right? We get better maps. We know where everything's at. And then the automation can take place, because it's only really as good as it's programmed, right? As it's said in there, what people are scared of. But as long as we're programming those elements into it, I think that's what will help. And we probably have a long way to go and a lot of things to learn. But the way we progress so far is amazing, right?
Yeah, it's interesting thinking about navigating an urban environment. If anybody's ever been to New York City in the winter, you could go down one street, and just because those buildings are taller, the wind gusts down that kind of tunnel is so much worse. So these are the type of calculations we haven't even thought about, which we'll be confronted with when we start to scale and move into, I guess, more dynamic environments like cities.
Totally.
Yeah. I mean, the findings, the accuracy of the delivery, the machines definitely did it better. I do think it is funny that the flight speed was higher with the manual pilot. I wonder if that's, if because the autopilot is programmed to really take safety, make safety paramount, fly a little slower, fly a little higher, do everything you can to make sure at all costs you're not going to crash into something, while here the manual pilots are kind of pushing those limits a little bit more, which is
I could use an extra, it took a dangerous turn that you might not take if you were taking all safety into account, right?
Yeah, totally. And you're even right about they're flying higher, which requires the flight time to be longer. Obviously, it takes more time to go up higher and come back down lower to do the delivery. So that also, plays into the battery consumption as well. As if drones are flying higher and their flights are longer, maybe that's not a good thing if the battery consumption matters so much. Right. So it's definitely an interesting debate.
Yeah.